Have you ever seen these formulas in your math textbook and wondered why they work? One of the most important things to do as a critical thinker is to question everything. In mathematics, this is done through deductive reasoning. Now, deductive reasoning was developed by scientists and philosophers who are trying to understand the universe around them. But what exactly is it? It is also known as the top-down approach, and it is the process of using what you know to be generally true in order to make an inference about something specific. Now, the fancy textbook term for this is the law of detachment, which simply states that if my general statement is true, then my specific statement is also true. When you create a chain of general statements and then work your way down to a specific conclusion, you get the law of syllogism, which simply states that if my general statements are true, then my specific conclusion is also true. Now, when doing a mathematical proof, these are the 3 steps you take. First, you note down your givens or your observations, things you can see from the problem. Second, you reason using deductive reasoning, using general statements to infer specifics. And then thirdly, you reach your evidence-based conclusion. When doing this, it is crucial that you do not make assumptions you're not 100% sure are true. For further clarification, let's take a look at this illustration. So let's say I come to school one morning and I realize that my binder is missing. So this realization would be my given or my observation, what I can see. But then I remember that earlier this morning when I came to school, I had my binder. So I would make the general statement that I lost it sometime between now and when I got to school. And so I would retrace my steps and work my way backwards through my morning in order to eliminate potential locations such as the library or the front desk downstairs. And so if it's not at the library and not at the front desk, then it must be outside the front gate. And so that's my evidence-based conclusion. So this idea of using what you already know in order to reach an evidence-based conclusion is the same concept used in mathematical proofs. Now that we've understood the general concept, let's take a look at an example. So let's say we're asked to prove the distance formula. Now this formula can be used to find the distance of any line in a coordinate plane. So let's say we have line D with endpoints A and B, and those are just their corresponding coordinates. So the first thing to do is get our 2-column proof, and then from the diagram we can tell that D is the distance between endpoint A and B, and that's our given. And so if we were to add another point, C, in order to form a right triangle, based on its position, we can see that it would have the same x-coordinate as point B and the same y-coordinate as point A. Now we know the Pythagorean theorem is true, so using what we know to be true, we can make the inference that AB squared, the hypotenuse, equals AC squared plus BC squared. And then if we substitute in D squared for AB squared, we still get the hypotenuse squared equals the horizontal distance, the difference in the x's, plus the vertical distance, the difference in the y's squared. And so when we take the square root of this, we get the distance formula. Now when studying, it is crucial to ask why, ask the reasoning behind a concept. This is because rather than just memorizing and cramming information into your head, you have a clear understanding of the concept and remember it for good. Now this simple 3-step process of using observations and then reasoning deductively in order to reach an evidence-based conclusion are crucial in mathematics, but even go beyond that. These thinking skills are applicable in virtually any career field. For example, scientists use these thinking skills when testing their hypotheses. Lawyers use these thinking skills when trying to convince a jury that their client is innocent, and so on and so forth. But it's a simple, everyday problem-solving technique that we use to solve problems in our homes, in our communities, and in our world. And it all begins with a simple thought process.